Okay, so I got this 3D printer. It had problem with heating, so we are going to first see what is the symptoms of the problem, and then we are going to try to fix it. I'm heating up the bed and the nozzle just to see if the MOSFETs and board is working fine. As we can see, the temperature reading is on high present, but hot end temperature is not rising up. Second thing we are going to do to identify the problem is to see what are the resistance values of the thermistor and heating element. Now you can touch ends with hands, or you can try your best not to touch them, but you should see identical values. Only difference can be the watts value of the heater. So in this case there is too much of a difference between resistance value of heater that is in the printer and the one that is new and working fine that I measured earlier. So now I have soldered the ends, connector ends, to this new thermistor, and we are going to this new heating element, and we are going to see how it will behave. Now I have connected it to the printer. I have plugged in now the mains cable, and we will see how this will work. Now I'm going to put in the value, and the value is too low. Now the thermistor is not near the heating element, so we cannot read the temperature, but we can feel if the heating element is heating up. Next thing that is important is cable management for this printer. Cables are all over the place, so first things first, we are going to disassemble this hot-end assembly and see what is actually the problem here. Let's go. So I have removed the part with fans and bill touch. Now I'm going to remove the hot end assembly. It is straightforward process, and right now I can feel that it's completely clogged up. The person that brought this printer to me used it to print ABS, but with this stock hot end it is not the best option to print ABS on higher temperatures. So now I am disconnecting all the cables, and I am going to remove this hot end assembly and heater and thermistor and so on completely, and see what is happening there. So we can see that there is duct tape around the thermistor sensor, and the person that did the upgrade did not have the right connector, so he wrapped it up. And now when I try to pull it out, the cable broke. So we are going to replace those connectors, and we are going to make them more sturdier and better. Now I have removed the sleeve, and I'm going to inspect all the cables just in case that something does not work, is broken or does not work properly because of the connection. Now the heater is not stock, it is upgraded, and as we can see, this person did not use soldering, and he just clamped them together with metal. So there was a stress relief point and it broke some wires of the thermistor, and the thermistor did not have good contact, but I was not completely sure if the thermistor is broken or if only this contact is causing the trouble. So I will try to heat thermistor up directly with power supply later on. Now I need to disassemble this part just in order to remove it from the 3D printer. And we can see the problem now. It is completely clogged up and heat block is destroyed also. Now this cold end we can clean up, but heat block will need replacement. We will see that later on in this video. Also the nozzle. So this is how it looks. Completely clogged up. Heater element is not completely properly placed. So now I'm going to remove the PTFE tube, and I have freed the hot end assembly now. As we can see here, I have adjustable power supply, and I'm going to try to see if the power is coming to the hot end. Now I will test to see if the cable is working, and it's working. There is power to the black and the red one, or plus and minus, but the heater is not picking up on any of the power, and it is not heating up. So I am now trying to directly connect it to its legs, the power supply, but in this case also it is completely and totally destroyed, so it won't work. Now I have added the new heater. Before this I have disassembled everything and cleaned up the hot end assembly and made it ready for the steps that will be later on in the video. Now in order to get all these cables through the sleeve, we will need to wrap the arrow with the tape and push it through this sleeve cable. Now this is going into the sleeve, and we will see this is the easiest method. Now I am going to push through also the BioTouch cable so that everything is going to this one place and without zip ties, just for better mobility of the printer XY core system. Now everything went through, and I am going to do some cable management with the zip ties and so on, just to hold it in place. Okay, so I have added a little bit, left a little bit of extra of the cables for heating element, just in case if we need it, and we also need to make a pressure relief point in this system where the connection is made, just so that this brittle cable does not break. Now I'm looking what the cable goes where, because we have thermistor for heating hot end and hot bed and so on. Now taking the isolation is not easy job here, but we will see that later on. We can see that now. You need to try it a couple of times. thermistor wire is very brittle and small, so we will do this separately. Now I am reusing old connectors because I did not order any new from Chinese websites. So I had just enough connectors for this project, and I will order new ones, but with the old ones you will need to push the head of the connector out of the body and solder it directly, and then push it back on, and you will have the clip that you will need to push down when pulling the connector out of the plastic body, and to push it a little bit up so that it will connect to the plastic later on.
Let's go.
Now I'm checking thermistor value, just to see if this connector is soldered properly and is making good connection. This is probably the most important part of the repair. You need to have resistance on thermistor end so that you will not have short. If you have short, you will fry your Arduino board. Now I'm trying to wrap heating element cable around, but because of induction and because it is high current cable, I don't want to risk causing fire, so I'm just putting it like normally. I have some extra cable management parts. I don't know how this is called, but I decided to wrap it around just so that I will protect this cables from the hot end. It is important to leave enough meat for cables to have stress relief, so that from movement of the printer tool head and printer parts, the cables will not break inside or make some connection with each other, because this is quite sensitive equipment here.
Let's go.
Now I am going to clean the PTFE tubing, and the top of the PTFE tubing that has direct contact with the nozzle is destroyed completely, deformed, so I cut it off. And now the next problem is that PTFE tubing is not long enough, so I will need to use a hot end fix for Creality hot ends in order not to install a new PTFE tubing, because I don't have a new one. But I have small pieces that I can use for this fix, and that work fine. If we are not going above 220 degrees for printing and so on. Because every PTFE tube that I had deformed, no matter what is the temperature after some time. So now I'm going to clean the cold end of the hot end, and you can see what ABS did to this hot end. It completely destroyed it.
Let's go.
Now I'm cleaning this heat break also. This is stock heat break. I'm impressed how long this printer lasted without any repairs, because everything was stock. I expected heater that broke. That was the first part that broke, but this was used for a long time. With plastic that was not supposed to be printed on this printer, because this only goes to 220 with this system.
Let's go.
So I asked the person who's owner of this printer, and he decided not to upgrade this system to a 3D level. So this is the reason why I'm cleaning this this stock setup. Otherwise I would not even touch it, because it is too much of a hassle. But he will use it for some time, make money, and probably buy a 3D nozzle or something, because it's the easiest system to use for this. And we will later on also see why. Okay, so the next part is there was tape around this wire, so I decided to see what was the case here, and the cable was damaged. So we will push the tab, metal tab, and remove the connector's metal head from the plastic body, and we then can put on it a bonjour or shrinkage tubing, and then isolate this wire. Now I have added the insulation tape, like textile, just for cables to be extra safe from the zip tie, so that zip tie won't cut into them. So the next part is cleaning printer, and this printer was not deeply cleaned in a long time, so I am just using wet wipes and cleaning the most that I can clean. Same as with hot end. Now the guiding part of the assembly and is not also cleaned, so I will remove the old lubrication that was dusty and black, and I will put the new one that the universal new one.
Let's go.
It is important to clean your printer because there is a lot of metal particles around the 3D printer, and sometimes they can go and make contact with the board or with some parts and destroy the main board. So cleaning is the best step for preserving your 3D printer, because every fix and repair is time consuming and it's expensive. at the end of the day. So I am manually moving Z-axis up and down, just so that I can clean the assembly and lubricate it properly. It's important to repeat this process a couple of times because there is a lot of junk and gunk in this assembly, just so that we can remove every piece of it. Now I have printed the fix for the hot end, and I'm going to implement it right now. For this fix, it is important to use 30mm PTFE tube, length of PTFE tube. So I'm going to cut it a little bit longer and then cut it to the size later on. Now I'm measuring the PTFE tubing and it is fine. I'm going to cut it. I will have like a couple of, maybe 1mm extra and or less. Now these surfaces need to be flush or straight, because we don't want plastic to come from the sides of it. Now this is going in the heat break assembly, the part that is connecting hot end and cold end of the hot end assembly. Now I have cleaned this up. I have disassembled it with heat gun because the thermistor was dead. I could not heat it with thermistor and power supply. Now I am putting all the parts in and everything is fine. This is the best solution because when this PTFE tube gets deformed, you will not need to change the half of meter of PTFE tubing. You will only need to change 30mm or 3 cm of PTFE tubing. And it's making this process faster because you can remove a hot end easily without heating up the cartridge, heating cartridge. So the next part is putting everything together. I am using the old heat block, and it was too much damaged, and I tried to use the part that is putting the thread in the metal just to clean the plastic, but there was too much of a gap between the threads. So I decided to use the new block. It was actually not the new, but from the other printer that I upgraded to a 3D nozzle. So this process I did a lot of time, and usually it works. And you can screw in the nozzle and so on, but this time it did not work. Maybe it was me, maybe it was this threaded part or tool that I used, but I have the Newton meter, precise one that goes from 1 to 5 Newton meters, and I was not able to tied up this nozzle properly. So I'm going to mount it, and in order for a nozzle to be properly mounted, it needs to be heated up a couple of degrees higher than used temperature, and then I decided to use 1.5 Newton meters of torque to tighten this up. Now I'm doing some cable management, some tinkering and so on, just so that this tool head will have the best cable management and moving options. There is a problem with putting heating cartridge through the heat block, but as we can see, I used some metal parts in order to scrape the plastic that was inside, and now it went through easily.
Let's go. Let's go. Let's go. Let's go.
Now I'm going to heat the hot assembly and to tighten the nozzle at 230 degrees to 1.5 Newton meters. Or in this case 220. Now we will see soon that when I tighten the nozzle, there is going to heating error is going to occur. Now I think that it is due to pit calibration probably, because when I put the cold tool in order to tighten this hot end, the heating of the block did not go as it was calibrated, so error occurred. Now I'm firstly removing the old nozzle and I am putting the new one and tightening it. Now the heating error occurred, and if it was due to thermistor, I think that the board would shorten. The board would be shorted, but I think that this is only due to, I don't know, some unforeseen circumstances. Now I have restarted the printer and everything works fine. Now I'm going to push a new filament in, and I'm going to clean the PTFE tubing from the EDS, and I'm going to see how the flow is going. How good is the flow? So there is no cloggage in this nozzle. It's brand new. As we can see, the flow is perfect. Now this is when I have cleaned up the nozzle and put silicone protection on heat block. And this is the final result. Printer is ready, everything is tightened up and ready to go. This was the relatively simple fix, but it took a lot of time to disassemble everything and to put everything in proper order and to fix everything. So it took me like, I don't know, 3 hours, 4 hours, 5. I did not count to fix this problem. What I would recommend for people to do, I'm not, financial advisor or something like that, but from my experience, the best option is just to upgrade the complete hot end, and it would be hassle-free. Because if you use these type of printers that are stock and that are not the new series that have artificial intelligence and that are a little bit easier to maintain, you will always need to fix them and to know how to use them. You will always need to tinker with them. So maybe just buy upgrade kits, nozzles. I had good experience with A3D. They are not sponsoring me or anything right now, but that's just my experience. And yeah, that's it. See you in next video.